Welcome to Maths for All. I'm Aisling Flynn. This is Functions 1.3 Linear Functions. So we're going to learn about linear functions by graphing those functions, and you might get instructions such as these. Graph the function f of x equals 2x minus 1 in the domain minus 4 less than or equal to x less than or equal to 4, where x is an element of the real numbers. Okay, so what does that mean? We're asked to graph the function f of x, so find the outputs for the function 2x minus 1 in the domain. So our inputs will begin at minus 4 and they will finish at plus 4. Okay, and everything in between. So we may use a table to do this, and I've already done this. Okay, so our inputs on the left hand side, we see x. We begin with minus 4 and we go up in steps of 1 to plus 4. Okay, we could take many more steps because we're to include all the real numbers, so between those values, but this will give us plenty of points to sketch our graph. Okay, now let's take the function and we'll put each individual input into the function. So we've got 2x minus 1, so we have to multiply the input by 2 and then take away 1. So the first one you see there is 2 times minus 4 minus 1, so that would be minus 8 minus 1, which gives me an output of minus 9. Okay, then you go ahead and you change the input, so change the input each time and calculate, and you'll see we get all these outputs, minus 9, minus 7, minus 5, minus 3, and so on, and then into the positive values. Do you notice a pattern? So really you've kind of met these in patterns before. Do you notice that there is a common difference? So to go from minus 9 to minus 7, you go up 2. And when we did patterns, we called this pattern arithmetic, or we also called it linear. Okay, so, and why was it called linear? Because when we put it on a graph, it looked like a straight line, and we could see that the common difference was constant. And in a little while we see that common difference, that same jump each time, equates to the slope of our line. Okay, so there's all our outputs. We're going to graph it in a minute, but to get all those outputs may be time consuming in an exam. Okay, so in actual fact we can do this on the CASIO calculator using the table mode, and that's what I'm going to show you next. Okay, so here we have our CASIO calculator, and we're going to use it to create the table for our function. Okay, so the first thing we need to do is we need to select a different mode. So we go to mode. Okay, here's mode. And you can see the menu there, and number 3 on the menu is table. So I'm going to press number 3 to select that. And here you see we have f of x equals, so it wants us to type in our function. So if you recall, the function was 2x minus 1, so that's 2. And to type x on your CASIO calculator, bring this closer, you see it here written in red. It's not the best visibility on the pink calculator. Okay, there's x. X is in red writing, and to select red writing you use the alpha button. Okay, so there we have 2 times, so alpha x, so there's 2x minus 1. So that's my function entered, and I press equals to enter that. Okay, now the calculator asks me what value do I want to start at, and I want to start at minus 4. So minus 4, and I press equals to enter that.
And what do I want to end at? Well, I want to end at plus 4, so just 4, and press equals to enter that. And what steps do you want to take? I want to go up in steps of 1, so I'll leave that 1 as it is and press equals. Now, here you see a table with all our inputs under x and our outputs f of x on the right here in this column. And you can see, I can scroll down through them, and you can see that I have the full table that we had done on the previous slide. Okay, and that's the end. There's 9 values. Okay, so that's how you use your calculator. Now when you're finished, you see, if you go back, you remain in table mode. If you want to go back to regular computations, you press mode and you press number 1 for just computing. Okay, and there you have it.
So now we're going to graph our function 2x minus 1. Okay, so we'll have our graph paper, and remember that the horizontal axis is for inputs. It's the x-axis. So this one we're taking in from minus 4 up to plus 4. And the outputs we will measure off the vertical axis, that's f of x, or sometimes we call it the y-axis. Okay, so our first point appears down here. Okay, so if you remember from the table, the input was minus 4 and the output was minus 9. So minus 9 is down here. It's halfway between minus 8 and minus 10. Okay, the next point was minus 3, minus 7. Then we had minus 2, minus 5, minus 1, minus 3, and then we had 0, minus 1. Okay, we'll note that now for later. This is known as the y-intercept. Okay, and it's where the function crosses the y-axis. And the value of x at this point is 0, so that was our input. And if you get f of 0, we have 2 times 0 minus 1, the result is minus 1. So putting x equals to 0, using that as an input, always gives you the y-intercept, so we get minus 1 there. Okay, continuing then. With each increase in x value, so every time we go 1 bigger, we saw this before, f of x increases by 2. Alright, so if we take this one here, the x value is 1, and then the next one after, the input value is 2. So as you go from 1 to 2, the line climbs by 2 steps. It goes from 1 to 3. Okay, so every time you take a step to the right by 1, the function goes up by 2. So with each increase in x value, the value of f of x increases by 2. And this function here is an increasing function. As we go from left to right, it is rising. Okay. And another way of describing that increase with every step to the right is we call it the slope. We can say that the slope of this line is 2. For every step to the right you take, you go up 2 steps. Okay, we also have what's known as the root of this function. The blue arrow is pointing to that, and it is where the function crosses the x-axis, or where the function has a value of 0, or the y value is 0. To find the root algebraically, you put the function equal to 0. So you're asking, when is the function equal to 0? So when is 2x minus 1 equal to 0? So that's a straightforward linear equation. You would add 1 to both sides, okay, and you get 2x equals 1. And then to solve for x, you divide both sides by 2, and you get 1x equals to a half. Okay, and that's what you can see there, that the function crosses the x-axis when the x value is halfway between 0 and 1, x is a half. Okay, and that's known as the root of the function. Okay, so here's another one to do, just to repeat the process. Graph the function f of x equals 5 minus 2x this time. Okay, in the domain from -3 to +3, where x is an element of R, the real numbers. Okay, so again, you can create your table like so. Here's our inputs, this time starting at -3 and finishing at +3. My function says take 5 minus 2x, so begin with 5 minus 2 times the input. Okay, now use brackets because the input here is a negative, so it's 5 minus 2 times -3. So -2 times -3 means is +6, and 5 plus 6 gives 11, and so on. Okay, and don't forget you can use your calculator now, and your calculator will do all of that for you. Okay, and what does that look like on a graph? So it looks like this. Again, inputs on the x-axis, and this time we were interested from -3 up as far as +3. Okay, and the outputs are measured off the y-axis. So there's our y-intercept. Okay, so it's where the function crosses the y-axis, and at that point the value of x is 0. So if you look to the x-axis, that point is directly above 0. Okay, so to find it algebraically, you get f of 0, so make x 0, and you get 5 minus 2 zeros, which is just 5. And we can see in this case that with each increase in the x value, as you go across one step, so if we look up here, as you go across one step, we're going down 2, we decrease by 2. Okay, so this is a decreasing function. As you go from left to right, the line is falling. And we can also say that the slope of this line is -2. The root of this function is where it crosses the x-axis, so we can see it here. Okay, it's some place between 2 and 3. Okay, so it looks to me like 2.5, but let's check it out. At this point the y value is 0, so the function, the output, is 0. And to find the root algebraically, we put the function equal to 0. So we'll say 5 minus 2x equals 0. So the first step is to take 5 from both sides, and you're left with minus 2x equals -5. And then we'll divide by -2 both sides to give 1x equals, and solve for x. So dividing by -2, minus divided by minus gives us positive. So we get 5 over 2, or 2.5, 2.5, which is what it looks like there. Okay, so linear functions. Linear functions describe a line shape when you put it on a graph. Linear functions have the general form, so this is what they look like. F of x is equal to mx plus c. Okay, so if you remember on the previous slides, we had the first function we had was 2x plus 1, and the second one we had was 5 minus 2x, but you could rearrange that if you wanted to say minus 2x plus 5. So they have the form of something x, so mx plus c, where c is a constant, a number. Okay, it could be in our case it was +1 or +5, but equally it could be a negative number. From the previous examples we can see that the coefficient of the x is the slope of the line. So if you remember, our first function went up and its slope was +2, so you can see 2 here beside x. The second one went down and it had a slope of -2, so here you can see -2 beside the x. So the letter m here, whatever is beside the x, represents slope. And the constant term, so the number term, described where the line crossed the x-axis. Okay, so if you go back, that was a -1, wasn't it? This one here was -1. If you look back through the slides, the first one crossed the y-axis at -1, and the second one crossed the y-axis at +5. So the constants give you where it crosses the y-axis. It's called the y-intercept. Okay, so here's an example. Draw the graph of the function f of x equals 3x minus 1 in the domain. So x is between -2 and 3, and then we have to use our graph. Okay, so drawing first, you want to work out your table. Okay, so my x value are going to start at -2, -1, 0, 1, and finish at +3, and my f of x will be the outputs. Now I'm just going to work out 1 just to see. So 3x minus 1 is my function. Okay, so if I do 3 times -2 minus 1, I get -6 minus 1, which is -7. So the first output is -7. Now you can work them all out, or you can go and use your calculator as we've just seen. So if you want to pause and use your calculator or work them out, go ahead. And the outputs turn out to be -4, -1, 2, 5, and 8. Okay, and what these make here are called couples. If you want to list them, you can. The points we have for our graph are -2, -7, -1, -4, and so on. 0, -1, and so on. Okay, so to draw my graph, I'm going to use the gridded section over here. Now, of course, you will have better graph paper and you will be using a ruler. Okay, so I'm going to put my x-axis halfway along here. Okay, and my y-axis are down along here. Please use rulers. Okay, x is for my inputs, and my inputs this time are from -2 up as far as +3. And my outputs range from -7 underneath to +8 above the x-axis. So I'm going to go in twos, I think. -2, -4, -6, -8, 2, 4, 6, 8. Okay, now to plot my couples, so -2 on the x-axis goes with -7 on the y, so about there. -1 is at -4, 0 is at -1, 1 is at 2, 2 is at 5, and 3 is at 8. So you can see it's linear. You can also see from the pattern of outputs that the common difference is 3. So you're rising by 3 each time. So the slope of this is 3. Okay. Now you will use a ruler here. Okay. I'll do my best. We can see we have a nice line segment there. Okay. And that's my f of x. Alright, so that's the first part done. You get plenty of marks for drawing a function, and now we're asked to use your graph. So when the instructions in an exam tell you to use your graph, you must use your graph. Okay, you need to indicate where you find the answer from your graph to get full marks. You can do perfect algebra to find the same answer, but they're not interested in that. And also the word estimate is used. Okay, so if you're a little bit out, that's okay. You've drawn your graph, another student has drawn their graph. They can be slightly different and you can get slightly different answers. but because the word estimate is used, that is understood, and the examiner wants to see you interpreting and using the graph. So please show them that. So the first one says use your graph to estimate f of minus 1.5. So the minus 1.5 takes the place of the x, okay, in f of x, and so this is an input, and the inputs are on the x-axis. So you go to find minus 1.5 on the x-axis. So my x-axis I'll find here, halfway between minus 1 and minus 2 is minus 1.5. Now to find the corresponding output is what we've been asked to do. You use a series of vertical and horizontal lines with your function that you've drawn. So show this to the examiner. This is where I got my answer. And I am getting an answer between minus 4 and minus 6. It's after minus 5. My answer to part 1, I'm going to say it's minus 5.4. Right, now that could be way out. I want you to see what your answer is from your graph. If you try it, you might get minus 5.3 or 5.5 or somewhere in that region, but they're all acceptable if you show where your answer came from. So show that dotted line on the graph. Part 2 says find the value of x. So we're trying to find x when f of x is 3.5. So this time we're given the answer or the outcome. So, and outcomes are on the vertical axis, 3.5. So 3 would be here, 3.5 would be about there. Again, you have better graphs than I do. So I'm trying to find the x value that would give that output. So we use a horizontal line here, use the graph lines on your ruler, and I'll drop it onto the x-axis, and I'm saying that x there is 1.5. Now again, your graph might give a slightly different answer, and that's okay. Okay, so that's that question answered. You can rewind and go back through it if it helps. And here's another example. This time the graph is drawn for us. The graph of the function f of x equals 2x plus 5 is shown. Use the graph. Okay, so use the graph. So we will use the graph to write down. When a question says write down, it means they don't want you to go off and do lots of algebra to find the answer. Okay, to write down, and the first part is f of 0. So f of 0. So 0 takes the place of x here. It's an input. Okay, so let's find 0 on the input axis, which is the x-axis. Okay, and 0 is here. So we're going to find the corresponding output. So for 0, it's just straight above it. The answer is 5. Okay, f of 0 equals 5. And number 2, we're asked to find f of 1. So 1 is my input this time. 1 is here. And we'll go straight up, hit my line. What's the output for that? F of x is 7. So f of 1 equals 7. That's that one. And third one is f of minus 1. So minus 1 is an input again. Minus 1 is here. We go straight up till we hit the red line and across, and we see that the output would be 3. Okay, so the third part there, f of minus 1 equals 3. Okay, part 4 says find the value of x, or write down the value of x when y equals 3. So y is 3. We use our y-axis. We find y is 3 and we want the x value. So hit the line and come back down. It's something we've seen already. X equals minus 1. Okay. And find the value of y. So we have to find y when x is minus 2.5. So x is minus 2.5. It's here. What can you see? That the line goes straight through here and it's at 0 level. So here y equals 0. Okay, just another point on that. Sometimes you may be asked to verify your answer using algebra. Okay, so if we're asked for f of 0, verify that answer. That was the first part. 0 is an input, so we do 2 times 0 plus 5, which is 0 plus 5, and yes, of course, we get the same answer, 5. So when you're asked to verify using algebra, you would be substituting for either x or f of x and showing that it's true. Now you do some of that, check your understanding with the quiz and do the written exercises to practice.